So we'll solve this question now. This question was asked in GATE 2024, okay, in sample paper, right? So when ISC Bangalore released its sample paper, okay, for GATE Data Science and AI, so they asked this question, right? So this was just a sample paper for GATE 2024 Data Science and AI, since GATE Data Science and AI paper was quite new to us. So this question was there, and no, I think nobody might have found the solution across the YouTube space or anywhere on internet as well, right? So we can solve this question, and this question was based on permutation and combination, as well as uh, based on the probability, right? So you have to use the counting techniques, okay? And here we have to distribute the objects into the boxes, and here they have given the objects are identical objects. So n, you can say n identical objects you have to distribute, okay, into m you can say distinct boxes, right? So this question was based on let me write here n identical, okay, objects into m distinct boxes, okay. So this will give you the total number of ways, okay, in which you can distribute n identical objects, okay, into m distinct boxes, right? That is a question. I mean, that is not the question. This will be the total number of case. Since what they are asking is, let us go through the question. Given n indistinguishable particles, it means n identical objects. Okay, you cannot differentiate. Okay, if number of particles are given, so you can say all particles are same, identical objects. Okay, and m, where m is nothing but greater than n, right? Okay, so distinguishable boxes means they are distinct boxes, okay. You are able to differentiate, yeah, this is the box, different, there are m number of different boxes. We place at random each particle in one of the boxes, okay. So you are going to place at random, okay, each particle in one of the boxes. The probability that in n pre-selected boxes, okay, so this is going to help you to find favorable number of ways in which you can get this result, okay. So what is the probability that in n pre-selected boxes one and only one particle will be found, right? So this line will give you the favorable number of outcomes, okay, remember this. And this will give you a total. So first of all, let us find total. We know that the probability is nothing but the favorable upon the total, right? I mean, in total everything is included, favorable plus unfavorable. So how to find total number of ways? Total number of ways, okay. The total number of ways can be found out, as we know that there are n number of particles, okay. So you can say that 1 2 3 4 and so on, there are n number of particles, okay. And there are m number of boxes, okay, and they are distinct boxes, and these particles are same particles, identical particles. So we have learned one technique, in my classroom program. I think you guys might have learned one technique called biggest method, okay, or you can say stick and stone method. So we can take some sticks here, okay. So here n number of identical objects are there, and now we are going to choose sticks, right? So how many sticks we can get, we can have here? So since there are m number of boxes, so we must take m minus 1 number of sticks. So here I'm just going to take sticks here, right? And these sticks are going to be m minus 1, right? So I think this is clear, right? Now you can say, you can now find the total number of ways. So total number of ways is going to be, you can add these two, right? So this is nothing but m plus n minus 1 factorial. Now you can since you have over counted, so you can just correct it also. So this will be m minus 1 factorial and n factorial. So this is going to be a total number of ways, okay, in which okay, you can distribute n identical objects into m distinct boxes, right? Okay, this is what. But the question was probability, okay, remember you have to find the probability, right? So what was the favorable outcomes? Let us see. We need to find the favorable one. So favorable is nothing but what? We need to first select n number of, you can see here what question they are saying. N pre-selected box. Okay, n pre-selected box. And each n pre-selected box, they must get one and only one particle. Okay, one and only one particle, right? So out of five, there are there are m number of boxes. Okay, so n pre-selected boxes. Okay, so you have taken n, you can say pre-selected boxes. Okay, and then you are giving, there are how many particles, guys? There are n identical particles, right? N number of particles. So these n number of particles will be placed in n pre-selected boxes. Okay, so how many particle will be left with you? Zero. The reason is you have to place, see, we have got n boxes. You take here n boxes, one box, two box, three box, and okay, these are n number of boxes, n boxes, and these are pre-selected boxes, and we are placing one, and because we have got n number of identical. Okay, so since all the particles are same, right? Since all the particles are same, so we will be having only one ways of doing this, right? And how many boxes are going to be empty? You can say that m minus n number of boxes remains empty. Okay, why they will be empty? Because because there are n number of particles only, right? So you're going to put one particle in each pre-selected boxes, and there are n number of boxes and n number of particles. I mean, pre-selected boxes are n, so m minus n boxes are going to be empty as well, because now you don't have particle to put. Okay, so this is going to be done in one ways, because all particles are same. Okay, because all particles are same, so this is going to be done by one ways only, one way. Okay, so there is a favorable number of ways. Favorable is nothing but one. Okay, and total is nothing but, you know, m plus n minus 1 factorial by m minus 1 factorial n factorial. So what is the probability, guys? The probability, required probability, is gonna be 1 by m plus n minus 1 factorial upon m minus 1 factorial n factorial. Now you can take the you can take this guy to the numerator here, so it can be written as m minus 1 factorial n factorial by m plus n minus 1 factorial. So I think many of you might have got the answer. Okay, so this was the solution. Okay, I think this is the answer for this question. Okay, B is the correct answer. Okay, so those who have attended my class, so they will never face any sort of problem, and those who did not attend my class, okay, they might face a kind of problem, right? I believe. Yeah, if you have attended my class, you will not face any sort of problem. Okay, so I hope you might have enjoyed the solution. So there is a, you know, technique I always discuss. See, we have got various technique. Okay, if we have got the case like n distinct object has to be distributed into n number of distinct boxes. Okay, so we have different case. Okay, and if there are n number of identical, you can say, objects, and we have to distribute into m number of distinct boxes, so there is a technique called Biggest method. Okay, we can choose some sticks as well, right? Okay, sticks we can choose, understand, and we can put it here, right? So this is very important to keep in mind. Okay, so I'm considering all the cases, and you see how simple this question was. So if you want to learn more, you can reach out to me. Thank you.